Hey there everyone, this is Anthony. Hope you're all doing well. Today we're going to take a look in this video about the next factoring technique. And this technique is going to be the difference of squares. So we said in the last video for factoring that we're going to see if there's a GCF, a greatest common factor, first. After we do that, then usually it's a little bit easier to see other techniques that weren't so obvious at the very beginning. But let's take a look at what the difference of squares is. The difference of squares is when we have either two variables or two variables of even exponents or integers, real numbers that we can take the square root of. And the idea is when we see something in this form, we're going to factor it, and it's going to be decomposed and look like this. So it's the square root of the first minus the square root of the second times the square root of the first plus the square root of the second. Whoop. Not sure why I put a 2 there. Okay, there it is. And let's go ahead and distribute this just to confirm that this is equal to this. So if we distribute the first term with each term in the second parentheses, we get x times x is x squared, x times y is positive xy. And let's distribute the second term with each term in the second parentheses. Negative y times x is negative xy. Negative y times y is negative y squared. When we combine like terms and simplify, positive xy, negative xy, those simplify, those go away, and we're left with x squared minus y squared, which is what we originally had. All right. So let's take a look at some examples while using this technique. Let's say we have x squared minus 4. So we first check to see if there are any GCFs. This has a coefficient of 1. 1 and 4 don't go into each other. There's an x squared here, but there are no x's, no variables in the second term, so there's no GCF. So let's take a look and see if the difference of squares applies here. This is a variable raised to an even exponent, so that works. This is a constant, an integer, that we can take the square root of and get a nice whole number. So we're going to apply the difference of squares, and remember the pattern. We're going to take the square root of the first, and we're going to subtract the square root of the second, square root of the first, plus the square root of the second. And there we have it. This is the factored form of x squared minus 4. Okay. If off to the side before you factor, if you want to take the square root of each of these, just to confirm, we can see, okay, the exponent is the same as the index, like we talked about in our last variable. So our answer is just the base. And let's take the square root of 4. Well, the square root of 4 is the square root of 2 squared. And now that we see that the index matches the exponent, our answer is the base. So these are the two values that we're going to put in our factored form. All right, let's take a look at some other examples. Let's say we have 3 minus 12a to the second power. All right. Now, right off the bat, you might think to yourself, well, Anthony, this is not going to work for difference of squares because you can't take the square root of 3 and get a nice whole number. You cannot take the square root of 12 and get a nice whole number. That is true. But let's try to see if we can take the GCF first. That was our first technique that we talked about in the previous video. So the GCF, there's a 3 here. 3 goes into 3 once. 3 goes into 12 4 times. So we can factor out a 3 first. And remember what happens when we factor out, we're dividing. So we're going to divide each term by 3. 3 divided by 3 is 1. Bring down the minus. 12a squared divided by 3. 12 divided by 3 is 4. And we're left with a squared, so 4a to the second. All right. Now that we've taken out the GCF, now we recognize, oh, look at that. There's a difference of squares here. The difference, because there's subtraction. Let's see if we can take the square root of 1 and the square root of 4a to the second power. So the square root of 1, well, this is the same thing as 1 to the second, right? Because 1 to the second is also 1. The index matches the exponent, so the answer is just the base. So this checks out. This is a nice whole number. Let's take the square root of 4a to the second. All right. Well, the square root of 4, remember that's 2 to the second, and then a to the second. Now, we haven't done yet in the video with the roots, we haven't done it where there are multiple, where there's coefficients and variables combined. But it's the same idea, where if you get both to be the same power, we're allowed to rewrite this as 2a all to the second. All right, this and this are equivalent to each other. And now that you see the index, which is a 2, it doesn't need to be there, right? The 2 matches the 2, so our answer here is just 2a. All right, and now that you see, look at that. This is a nice whole number. This is a nice whole number along with a nice whole variable. So the difference of squares applies, and we're going to follow the pattern. All right, the 1 and the 2a are going to go in the place of the x and the 2 in this case, or the x and the y in this case. So we're going to bring down the 3 that we took out as the GCF, and we're going to rewrite this as 1 minus 2a, 1 plus 2a. And this is our factored form of this. All right, we're going to do one more example just to make sure that we've got the idea. Get a little extra practice in here. All right, let's take a look at 16x to the 4th minus 81. So this one's a slightly different in that it's not to the second power, but you notice it's still an even exponent, so this will work for us. All right, let's check to see if there's a GCF. The numbers that go into 16 are 1, 4, and 16. And we want to see if any of these numbers go into 81. Well, yeah, 1 goes into 81, but that doesn't do us much good. 4 doesn't go into 81 because 4 times 20 is 80. All right, so that's not good enough. And then 16 is not going to work. 16 times 5 is equal to 80. So there's no GCF here, and there's no variable with the second term, so that we can take out a variable. So let's check to see if both of these if we can take the square root of each one. All right, so let's see, 16x to the 4th. Well, can we take the square root of each one? The square root of 16, well, we can break that down as 4 to the second. And then x to the 4th, we can break that down as x squared squared. All right. And now let's rewrite this a little bit. 4 squared times x squared squared. The bases, we're going to put those together because they share the same exponent. So 4x to the second squared. All right, and now that you see that the index out here matches the exponent of everything inside of the parentheses, because this and this match, our answer here is 4x to the second. It's the entire base. Okay. And let's take a look at the square root of 81. 81 can be rewritten as 9 to the second power. And because the index 2 matches the exponent 2, our answer is just the base 9. All right, so this does work. We get a nice whole numbers and nice whole variables with nice exponents. So we're going to rewrite this as its factored form as 4x to the second minus 9 and 4x to the second plus 9. And we have now factored 16x to the fourth minus 81. So I hope this video helps. If you enjoyed it, like, subscribe, share with your friends. Spread the word that there is math help on this channel. And I look forward to showing you in the next video. We're going to be talking about perfect square trinomials. So have a great rest of your day.